The autopilot is currently active, as denoted by its 3 green lights being on, but the throttle is under the pilot's control. Please increase the throttle to maintain a speed of Mach 0.85 to 0.9. With this training mission, you will learn how to employ the Viggens autopilot system. We have started this training already on the air, and we will cover the following aspects. Autopilot control bindings, disconnecting the AP, manual aircraft trimming, stability augmentation system, SPAC, attitude and heading hold modes, AP standard turn, altitude hold mode, and fine-tuning the AP using CSS. While the auto throttle can be considered a part of the autopilot, we will cover its use separately, during a landing training. This mission is based on the procedures described on the DCS AJS37 Flight Manual version 2.1. This training series is set on the Nevada map, and the approximate mission time is 20 minutes. By default, the pilot's body is shown. You can use left shift plus P to hide it if you prefer. When a voiceover tells you to interact with a cockpit element, wait until the voiceover has finished, before performing the interaction. If you are repeating the mission, note that most voiceovers can be skipped just by pressing the spacebar. Press spacebar to begin. The Viggens autopilot makes use of the trim subsystem of the flight control system to make automatic movements of the control surfaces. Because of this, we will briefly cover the manual use of trim on the Viggen. First, ensure that you have binded the control stick's trim hat to your own HOTAs, as shown on the figure. Press spacebar to continue. Another control that you may want to have binded to is the autopilot quick disengage button, which on the real aircraft is located at the flight stick. Next, we will disengage the autopilot, but be sure to hold the flight stick to retain control of the aircraft, as we have currently an asymmetric loadout which will make the aircraft drop the right wing. Press the AP quick disengage button, now. Good, the hold modes of the autopilot have disengaged, as can be seen by the ATT and HOD lights going out. Note that the SPAC stabilization mode was deactivated as well, and its light has gone out too. We will learn more about the autopilot stabilization mode later on this mission, but for now please re-enable it, by clicking on its light. Now, use the flight stick to level the aircraft. The training will continue then. Even if the aircraft is now level, note the force you need to maintain on the flight stick to keep it so. You can use the trim hat to help you relieve those forces. For example, give the trim hat 2 or 3 pushes to the left, and at the same time stop from applying so much left force on the flight stick. Keep adjusting the roll trim, with left or right movements of the trim hat, until the aircraft flies level without you having to apply lateral pressure on the stick. Press spacebar once you feel that you've got the roll trim right. Next, perform the same process with the pitch trim, giving the trim hat a few forward pushes, to bring the aircraft nose down towards the horizon line, at the same time allowing your hand to stop pushing the stick forward so much. Keep adjusting the pitch trim, until the aircraft no longer wants to raise its nose. On the left side of the ADI, there is a small vertical scale where you can check your vertical speed. Try to leave it at 0 as much as you can. Press spacebar, once you feel that you've got the pitch trim right. To better visualize the trim effect on the aircraft's control surfaces, press right Ctrl plus Enter, to enable the controls overlay on the bottom left corner of the screen. Good, the large diamond is the current position of your physical flight stick. Move it a bit to notice its movement. The horizontal axis corresponds to your roll axis, while the vertical corresponds to your pitch axis. The small diamond represents the trim forces currently being applied. If you were not using trim, then your hand would be manually maintaining the flight stick on that position. The trim brings relief to your arm by holding that equilibrium position for you. Press spacebar to continue the training. The Viggens flight control system is really interesting, even more so when you consider that most of the aircraft design dates from the 60s. The Viggen is not fly-by-wire, but it's not quite fully fly-by-direct linkage to control surfaces either. The basic flight control system is directly linked to the control surfaces, but that's only half of the system. The autopilot SPAC component is needed to make the aircraft fly as intended, using a flight control mode called CSS, control stick steering. Do not disable SPAC, as without it the flight control system will operate in a degraded mode, called GSA, Grunt Steer Automat, which is only there as a backup in case of a system failure. Without SPAC you do not have access to the full elevon authority, because a part of the deflection range on the outer elevons is reserved for the autopilot, and cannot be controlled via the basic flight control system. The aircraft is perfectly flyable in GSA, but because of the reduced elevon authority and general reduced stability, there's a whole bunch of operational restrictions that apply. Some normal operations become outright dangerous without SPAC, like using the thrust reverser for example. Now that we have the aircraft trimmed, we can get a feeling for flying without SPAC. Press the autopilot quick disengage button to disable it now. Good, next tug the flight stick left or right to bank the aircraft a little, and then tug it quickly in the opposite way to return the aircraft to level flight. Notice how the aircraft seems to oscillate a bit when performing these actions, making it hard to fly smoothly. Now, do the same in pitch, quickly pull the flight stick back a bit, and then push it forward to return to level attitude. Notice again how the aircraft oscillates and requires more effort to return to straight and level flight. This is how the GSA flight mode feels. Re-enable the SPAC by clicking the highlighted button to return to the normal CSS flight mode. Good, now try the same maneuvers and notice how much easier they are on this mode, without all the oscillation and bouncing around that GSA had. Press spacebar once you are on straight and level flight again, and ready to continue the training. ATT is the attitude hold function. When engaged with the ATT button, the autopilot will attempt to maintain current flight attitude in both pitch and roll. Keep in mind that the autopilot has no control over your throttle, so if you set a pitch up attitude, the aircraft will start to slow down, and if you pitch down, the aircraft will speed up. So, adjust your throttle accordingly to maintain a constant speed as much as possible. Let's give it a try. Use the flight stick to roll the aircraft 10 to 20 degrees to the left, while at the same time pushing it forward a bit, to around 2 to 3 degrees nose down. Good, now press the ATT button to enable the attitude hold autopilot mode. Now release the flight stick. The autopilot will keep the aircraft in a slow spiraling descent. At speeds over 650 km per hour, the bank angle is limited to 60 degrees, while at less than 230 km per hour the maximum allowed is 20 degrees. The figure shows the linear progression of this bank limit at intermediate speeds. This bank limitation applies to all autopilot modes: attitude hold, heading hold, and altitude hold. To deactivate this autopilot mode, just press the ATT button again. Do it now. Very good, now level the aircraft. If you are in a bank lower than 7 degrees, when you press the ATT button, then instead of attitude hold, you will be enabling a heading hold mode. Let's try it. Pull the flight stick enough to place the aircraft on a slight climb, no more than 3 degrees nose up, while placing the aircraft on a slight bank of around 5 degrees. Good, now press the ATT button. The autopilot has engaged in heading hold mode, because you were banked less than 7 degrees. You can tell because the wings were automatically rolled to a level attitude. On this mode, the autopilot will maintain the present course. The pitch angle is unaffected. If the aircraft drifts from the set course, the AP will steer the aircraft back onto the set course automatically. Heading hold mode is not available if the landing gear is extended, so attitude hold engages instead at bank angles lower than 7 degrees. Press spacebar to continue. When you are on heading hold mode, the trim hat can be used to enter a standard turn mode, in which the aircraft will maintain a constant bank angle to either left or right, depending on which direction the trim hat was pressed. Let's try it. Press for a moment the trim hat, do not keep it pressed, towards the direction closest to our next waypoint, left or right. The direction to our waypoint is indicated by good. The autopilot has banked the aircraft towards the commanded direction. The bank angle is dependent on the current airspeed of the aircraft, in order to yield a constant turn radius of 4.1 kilometers, if the airspeed is less than 0.8 Mach. Above that speed, A constant bank angle of 45 degrees is flown instead, thus the turn radius increases according to increasing airspeed. The change in bank angle causes a slight nose-down moment, which is automatically countered by a change in pitch movement to maintain altitude. The direction of the turn can be reversed by pressing the trim hat in the opposite direction of the present turn, twice. Try it now. Well done. Now use this standard turn mode to have the aircraft head towards our current waypoint. Press spacebar once you have the aircraft on course to the waypoint. HOD is the altitude hold mode of the autopilot. When engaged, the AP will attempt to maintain the current barometric altitude, while keeping both pitch and roll unchanged. Let's give it a try. Use the flight stick to roll the aircraft 10 to 20 degrees to the right, while at the same time pulling it back a bit, to around 2 to 3 degrees nose up. Release the flight stick. The aircraft is now on a slow spiraling ascent, bank to the right. To keep the bank, but maintain altitude, press next the HOD button. Very good, the autopilot will keep the aircraft in a turn, but now it keeps its barometric altitude constant. The bank angle is limited on the same way as we already saw when describing the attitude hold mode. You can fine-tune the set altitude by using the pitch trim positions of the flight stick's trim hat. Try it. Notice on the ADI how the horizontal yellow needle gives you feedback on the commanded altitude setting. Press spacebar to continue. Employing what you have learned so far, use an autopilot standard turn to head the aircraft towards our next waypoint. Press spacebar once you are on the correct heading. Whenever the autopilot is on attitude, heading, or altitude hold modes, the pilot can still intervene in the maneuvering of the aircraft, using the control stick. On the real aircraft, the pilot simply has to apply more pressure on the stick, about 3 times more than normal, to overcome the mechanical resistance of the AP centering units. On DCS, this is simulated by having to move the stick much more than normal. Let's try it. Carefully move the stick in such a way as to place the HUD's heading dot on the center of the flight path marker, as shown on the figure. Note that when you release the stick, the autopilot keeps the heading and attitude that you commanded. Press spacebar to continue the training. During transonic flight, between Mach 0.97 to 1.05, the autopilot enters a special attitude mode, which is called the HOD transonic mode. This is due to a lack of reliable data from the pitot tube system at such airspeeds. As this mode is not as precise as normal, you should refrain from flying on autopilot at transonic speeds near the ground. When on transonic mode, you can't fine-tune the set altitude with the pitch trim hat switch. The normal AP hold mode re-engages when leaving the transonic speed range. Let's give it a try. Move the throttle forward, onto zone 3 of the afterburner range. At Mach 0.97, the red transonic light illuminates, and the ATT and HOD lights start to flash alternately, to denote that you are now on the autopilot transonic mode. Keep the throttle at full afterburner. Once you pass Mach 1.05, the red light goes out, and the ATT and HOD lights stop flashing. You are now back onto the normal autopilot modes. Move the throttle back, out of afterburner, and let the aircraft slow down. Note that you will again pass through the transonic range while decelerating. Wait until the aircraft is back on the Mach 0.85 to 0.9 range, then readjust the throttle to keep within it. Press spacebar once you are back at cruise speed. Excellent. You have successfully completed this training mission on the employment of the Viggens Autopilot. Press spacebar to exit from the mission.